Alright, we're going to be multiplying and dividing rational numbers today. The first thing, if I'm talking about fractions, I want to see if I can reduce before I multiply. And I can think about that as I can reduce diagonally. I cannot reduce across. That doesn't work. So, for example, down here, if I look diagonally at these different pairs, which ones can I divide? Well, this one right here, I could divide this number by 7 and this number by 7. So instead of waiting until the end, I can reduce ahead of time. The next step is to multiply the numerators. So I'm going to do 7 times 1 here. 4 times 9 here, and because I reduced here, it's going to be 1 times 1. The next thing I'm going to do is I'm going to multiply the denominators. Remember, I do not need a common denominator when I'm multiplying. So here I've got 9 times 2, 7 times 11, and over here I've got 5 times 3 because of that reducing before I started. I then want to use the rules for integers. And one of the big rules for integers is that, I'm going to count. There's 1 negative, 2 negatives. So since I'm multiplying a negative times a negative, I'm going to have a positive answer. When I get to the end. Here I only have 1 negative, so my answer is going to be a negative when I get to the end. So here I've got 7 times 1 is 7, 9 times 2 is 18, and 7/18 is my answer. Over here I'm going to have 36 over 77, and that answer is going to be negative because only one of the numbers is negative. Now it's important to note that I can write this as negative 36 over 77. I could also write it as negative 36 over 77, or I could write it as 36 over negative 77. All of those only have one negative symbol, so any of them will work. On our last one here, we have one negative symbol, so we are also going to have a negative answer, and we're going to have negative 1/15. On this one, I could have multiplied and gotten 7 over 105, but knowing that I can divide those both by 7 and get to my actual answer would be very difficult. The next part we're going to look at down here is that if I have mixed numbers, I need to turn them into improper fractions first. And in order to do that, I'm going to take the whole number times the denominator plus the numerator. So 4 times 4 is 16, plus 3 is 19, so I have 19/4 times, remember we don't like to use that x because we're going to have variables soon and that'll look funny there. So instead, I'm going to use parentheses, and then 3 times 10 is 30, plus 9 is 39 over 10. Now, I unfortunately cannot reduce. I'm going to end up with some big numbers here. And in fact, when I do 19 times 39, I get 741 over 40. Because I only have one negative symbol, my answer is going to be negative. When I change that back out, the biggest problem I see is that kids tend to lose this negative right here when they turn it back into a mixed number. But I need to keep that negative. That's going to be negative 18 and 3/40 when I get done. You might want to stop and pause and try to do this yourself and see if you get the same answer as me. Over here, if I've got a whole number involved and there's fractions, I can make any number into a fraction simply by putting it over top of the number 1. And we have our little Beyonce song, sung to, if you like it, then you should have put a ring on it. Any number is a fraction, put a 1 under it. So just to help you get that stuck in your head a little bit better. So I'm going to turn this mixed number into an improper fraction. So now I've got 4 over 1 times negative 6/7/2. Now this one I can indeed reduce here. 2 divided by 2 becomes a 1. 4 divided by 2 is a 2. So I have 2 times 7 is 14. 1 times 1 is 1. 1 negative sign there, so I get negative 14 over 1, which is equal to negative 14. When I get in here with some exponents, remember if the negative is on the inside, that means I'm going to actually do negative 1/3 times negative 1/3 times negative 1/3 times negative 1/3. Whereas down here, it's going to be the opposite of 1/3 times 1/3 times 1/3 times 1/3. So you can see the difference here. This is going to actually end up being a negative because I want the opposite of something. And up here, 1, 2, 3, 4 negatives is actually going to give me a positive answer. 1 times 1 times 1 times 1 is 1. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. That same thing's going to happen down here. The only thing is my answer is going to end up being a negative. So this one's going to be an answer of positive 1/81, and this will be an answer of negative 1/81. Over here, that same thing's going on, although it looks like we have some different variables. Let's go ahead, or exponents, let's go ahead and make that one a 3 as well. I've got negative 2/7 times negative 2/7 times negative 2/7. A negative times a negative times a negative, so 3 of those. I'm going to end up with a negative, and 2 times 2 is 4, 4 times 2 is 8. 7 times 7 is 49, and 49 times 7 should know this, 343. Same thing's going on down here. The only difference is I've got the opposite. And so I end up with the opposite of 8 over 343, which is also a negative 8 343. Let's look at a word problem. Gary has half of a pizza left. He's going to split the pizza evenly between 2 people. How much will each person get? Well, if I have a picture, pictures make things so nice. So I cut that in half. Well, now I've got 1. Instead of 1, 2, I've got 1, 2, 3, 4. And each person then gets 1 of these, so that's 1/4. So that means that 1/2 divided by 2 is 1/2 times 2 over 1. I'm sorry, 1 over 2, which is equal to 1/4. I would need to put this over top of a 1, and then I flip it right here. It says, what if he splits it between 3 people? So then I would need to take this and divide it in 3 more pieces. So instead of 1, I would need to make 2 cuts. So I can make those like an X, and when I do that, that is not split between 3 people, but there's 1, 2, 3, 4, 5, 6 total. So that's like 1/2 divided by 3. Put it over top of a 1. And I get 1 out of 6. And here, if you look for a pattern, I'm like, oh, I end up flipping and multiplying, so I should get 1/8. So when I split it into 4 equal pieces, over on this side I get 8 total, so I am going to get 1/8, which would look like 1/2 divided by 4, 1/2 times 1 over 4, which is indeed 1/8. Continuing on to the back. For dividing fractions, we are going to keep the first fraction the same. I'm going to change division to multiplication. I'm going to flip, but we learned a big 7th grade word. I'm going to use the reciprocal of the second fraction. And then I'm going to follow the rules for integers. And so when I look at this, I'm like, oh my gosh, it looks so crazy. There's a fraction and a fraction. So a fraction over a fraction like that, every fraction is a division problem. So this is a fraction divided by a fraction. So negative 1/4 divided by 2/5, I start at the top. So negative 1/4 times 5 over 2, so I get negative 5 over 8 as my final answer. Please feel free to stop, rewind, go back and listen to that again, because every fraction is indeed a division problem. So negative 3/5, it's always the numerator, divided by the denominator. I have to keep change and use the reciprocal here. Now I could reduce ahead of time, and I get negative 6 over 7, sorry, positive 6 over 7. This one's already written as fraction division for me. And I get positive 5/12 on that one. This one, this is my division, so I've got 10 divided by negative 3/4, so 10 over 1 times negative 4 over 3, and I get negative 40 over 3, which ends up being negative 12, sorry, nope, negative 13 and 1/3, negative 13 and 1/3. When I multiply decimals, I do it just like double-digit multiplication. I just have to move the decimals at the end. I know my answer here is going to be negative, so I'm going to take my 3.2 times my 4.3. I multiply the number in the ones place, the 3, times everything above it in order. So 3 times 2 is 6, 3 times 3 is 9. Move over to the tens place, so I'm going to put in a placeholder. 4 times 2 is 8, 4 times 3 is 12. I am going to add those together, and then I'm going to move it over 1, 2 spots, so I've got a negative 13.76. Over here, a good rule that I like to follow is that if you have numbers with multiple decimal places, put the one with the fewest number of digits on the bottom, so that you only have to go through and multiply the fewest number of rows to be adding at the end, because we don't need to line up the decimal points when we multiply. 2 times 7 is 14, 21, 2, 28, 30. 2 times 2 is 4, 6, and 8. And I'm going to add those up, and both of those numbers were positive. And you count over the number of digits behind the decimal place is how many you count over. You can also go, well, you know what, the whole number is 4 times almost 3, so 4 times 3 is 12, so my answer should be close to 12, and if I put my decimal point in another spot, it would make a huge difference, one way or the other. So I will leave you with that. We won't worry about these problems at the bottom here, and let me know if you have any questions.